Everybody looking good? Okay, why don't you do a quick swivel of the camera so that the kids at North Central can see all the good-looking teenagers that are here? All the way. Yeah, there you go. These are all the good-looking kids. All right, happy Monday. Oh, wait. And there's David. All right, moving on. Here we go. You actually probably want to zoom in. All right, so if you guys remember on Stephen, you're going to want to zoom in.
How do you zoom in?
Which doesn't mean move it closer to my belly. Up here, okay, more on the job training. Here we go. Zoom in, zoom out. We want to zoom in. I want to make sure that they can see the stuff. And let's get one of the lights in the back.
I'll be there tomorrow.
All right. Lewis, thank you. David, thank you. Stephen, thank you. North Central, we're ready for you. Okay, on Friday, we talked about the big idea in calculus known as slope of the tangent line. My notation for that was tan. Say it with me.
Tan.
Tan. And there was a formula that we used to find tan at a particular point. Who knows the formula? Everybody knows the formula. Of course everybody knows the formula. We just did this on Friday. You have photographic memories. You all remember. It's got to be perfect. David, what is it going to be?
Tan.
Yeah. Yeah, I got that.
Limit
It's the limit.
x approaches a
Limit as x approaches a.
of f of x
F of x
minus f of a
minus f of a.
over x minus a.
Limit as x approaches a, f of x minus f of a over x minus a. Is everybody okay with this? Okay, the f of x minus f of a over x minus a. You guys know this. You've seen this before. What is that really? This is just slope. This is baby slope. Okay, but specifically, it's not tan. This is secant. All right, so I've got this thing called Geometers Sketchpad that I just want to kind of take you through the motions here. It's going to look a little bit different than what we did the other day, but it's going to be okay. I'm interested in this point P, which I'm going to call the point of tangency. Okay? David, what I would like for you to do is click option 1 where it says tangent segment at P. Okay, you guys know? Can you see the tangent segment? All right, this little black line. The goal is to find the slope of the tangent line at point P. Now, for all of you that can see up there, you're like, I know what the slope of the tangent line is. It's 2.819. True. Newton, back in the day, didn't have a laptop, didn't have Geometers Sketchpad, could not tell you specifically that the slope of the tangent is 2.819. He could say for sure that the slope is positive. Everybody okay? All right, good. All right, so what did he do? How did he go about finding the slope? You guys know the story. What did he do? What did he do?
Oh,
Choose another point. So click over here on arbitrary point. Okay, so what we're going to do is I'm going to have this thing that I'm going to call H, which is the distance from this point P. Create Q. Create Q. So I have some distance H. I'm going to go to the right H spaces to get to point Q. Is everybody okay? All right, and what we're going to do, secant PQ. Okay, secant PQ now creates a secant line connecting points P and Q. Now, thanks to the magic of Geometers Sketchpad, I can see that the slope is 4.285. Would anyone be satisfied and say, that's slope of tangent line?
no.
Ile, why not?
Because that's the secant line, not of the...
That's the slope of the secant line, not the slope of the tangent line. But in terms of an approximation, is it okay? It's okay. Could we make it better, Aaron?
Yeah.
How would you make this approximation better?
Well, for one, you could actually use the rest of the equation now that you have the slope of the secant line.
You've got slope of secant line, but in order for me to get to slope of tangent line, something special has to happen. Something special has to happen with the second point. Lewis, what has to happen with the second point?
H closer to X.
You want to get h closer to x? I disagree. It's not that we want to get h closer to x. H is how far right you are going. What do we want to do with h? We want to make h small. David, I want you to let h approach 0.
It will approach the slope.
Right? If h is getting smaller, that horizontal distance gets smaller, smaller, smaller. That is bringing point Q in closer. As Q comes in closer, 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 pay attention to the slope of PQ up here. What's happening to the slope of PQ? It's not just decreasing, it's decreasing in a very specific way. What's happening, Palma?
Until it reaches P.
It's getting closer. Q is getting closer to P. I agree. But what's happening to the slope of PQ?
It's starting to equal the slope.
It's starting to equal the slope of the tangent line. Everybody okay?
Yeah.
Right, I just wanted you guys to have like an animated visual of what's going on here. It's the same story from before. I want to find the slope of the tangent line at this one little point, but I can't do that, so I pick a second point. Because I have a second point, why don't you click let h approach 0 one more time? That'll stop it. There you go. So here's Q. Because I have a second point, I can make a secant line. I can calculate the slope of the secant line. And the slope of the secant line is an estimate for the slope of the tangent line. Everybody okay with that? Good estimate? You know, okay. Get better. Get me a better estimate, David. You're going to have to be really fast with this to get me a better estimate. Nice. Can you get a little better? Ooh, daddy likes. Slope of tangent line 2.819, slope of secant line 2.870. We're getting closer. Now, one thing, if you're really being astute about this, Q is always to the right of point P. But if I want to use the language of limits, I'm not just going to come in from the right. I also have to consider coming in from the left. So David, show from left. And then let h approach 0. What this does now, yeah, let h approach 0. What's going to happen now, and it might be a little too busy to actually see this, you're picking a point to the right of P, you're picking a point to the left of P, you're letting both of them get closer, you're letting h approach 0, and hopefully it's not a surprise, David, when you think you can stop it, so that they're really close, stop it. Man, you got skills. Slope of tangent line 2.819, slope of PQ 2.948, slope of RP 2.693. The slope of the tangent line is somewhere in there. And the way that we would get the actual slope, one way is to do this limit as x approaches a, f of x minus f of a over x minus a. Everybody okay? There is another way. David, you've done a great job. Using the notation of what's over here, we're going to say the other way to find tan at x equals a. Hi, bye-bye, thanks for stopping by. Is I'm going to define things a little bit differently. I'm going to say f of a plus h minus f of a all over h, and I'm going to take the limit as h approaches 0.
College visit, but it said 11:45.
Okay, Matt, whatever.
I'm gonna come back there.
Thanks. Okay, so one way to find slope of tangent line, f of x minus f of a over x minus a. The other way is if we're going to use this idea of h being your horizontal distance, a is going to be the place that you're interested. A plus h is just going to say, pick a point a little bit to the right or a little bit to the left. Find the slope between, find the vertical distance between those two, and divide by h. It's going to get you the same answer, it's just a different formula. Are all the friends okay? And this one might also look familiar as something that you guys did last year at the end of pre-cal. It was the derivative, yes. And we're going to talk about that. Everybody okay? Here's what I want you to do. I want you to find somebody else in the room. We've got 2, 4, 6, 8, 9. Excellent. One of you gets to talk to the kids from North Central. I want you to have like a short conversation with this person or video camera and 5 people on the other end. Tell them the whole story. How do you go about finding the slope of a tangent line? If you start with 1 point on a graph, how would you find the slope? Basically, what did Newton do? Pretty good? Get up, find somebody to talk to that you are not sitting next to. Whoever partners up last gets to talk to the kids in North Central.
Hello, where you at?
Oh, Andrew, talk to the kids from North Central. Talk to them about telling the story. Andrew, come on now. Here, to make it better.
All right,
it up,
we're
son.
going to talk about derivatives.
Okay. I don't know what you guys are looking at. Andrew and I are having a conversation. So, Andrew, tell me the story. How do you find the slope of a tangent line? What do?
You plot another point on the...
So you pick a second point, and then what?
And then you find the limit as the second point gets closer to the tangent line. So
I think the thing you want to mention, though, so you've got a point of tangency, like over here. You've got a second point, like over here. Oh, I can't really do this well.
connected would be the MC cant.
You connect those 2 points with a secant line, and then what?
And then you find the limit of the secant line as it approaches A, which is the tangent line.
Right, you want the second point to get closer to the first one. And so you're finding slope by doing like f of x minus f of a over x minus a. And you're going to take the limit as x approaches a. That's going to get you slope of tangent line. Okay, nice. Nice job. Nice job. All right. All right, let's get all the friends to go on back. I have never seen you all move so fast. That was the funniest experience so far. And let's turn the light back on in the back. Let's make sure you've got all the good notes going on here. I was really a little bothered when I realized Celeste was out because I wanted to have one of you guys talk to the camera. And I'm like, oh, it won't work. And then Aaron left, and I was like, sweet, we've got an odd number again. All right. All right, so we've got 2 formulas now for finding slope of the tangent line. Who can tell me one of them? Let's get some hands on this. What's one? 2 formulas. We just talked about them. You just talked to other people about this. Myra. Tan.
As x equals a equals limit of f of x minus f of a over x minus a
F of x minus f of a over x minus a. Limit as x approaches what? A. That's one of them. And then we get this new one. Polynomial.
M tan as x equals a equals limit as x equals 0 f with a plus h
F of a plus h
minus f of a
minus f of a
over h.
over h. And what's the limit we're taking this time? H is approaching 0. Both of these are telling the same story. You have a point that you're interested in, and in order to find the slope of the tangent line, you're going to pick another point and let the second point get closer, 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 closer. Both notations are telling you the same thing. Everybody okay? All right, our notation for the slope of the tangent line at x equals a, we know we're going to call the tan at x equals a. And as much as we might like that, there's another notation that you guys may have picked up on the streets from older siblings that you're talking to, having conversation about, that we're going to call the derivative. So rather than always saying tan at x equals a, we're going to say derivative. The word derivative is shorthand notation. It is shorthand notation for, hey, what's the slope of the tangent line at a particular point? Everybody agree with this? We get this under control? All right, and we're going to use f with the little prime of it. Now, a couple of things here. If f prime of a is positive, that means the slope of your tangent line is positive. Can you guys show me a tangent line with positive slope? What that would look like? Tangent line with positive slope looks something like this, right? What do you know about the function? What's the function doing? Must be increasing. So if f prime of a is greater than 0, then f of x is increasing at x equals a. You guys are mathematicians, so you're really good at patterns. What if f prime of a is negative? F of x is decreasing at x equals a. So if f prime of a is positive, the function is increasing at x equals a. Don't ever tell me function is increasing, that's too strong. Just like me, too strong. Okay, that was supposed to be funny, but apparently it wasn't. Okay, if f prime of a is negative, then the function is decreasing. That is the sloppiest little a I've ever written. If f prime of a equals 0, what's the conclusion?
Neither.
It's what?
Neither.
No, it is neither increasing nor decreasing. True. Can you guys draw a tangent line with slope of 0?
No. Wait, yeah?
Tangent line, slope 0. I think we can do that. You guys, if you're not sure, you might want to look back there. Right, your tangent line is, what's the fancy word for this?
Not defined. Wait, not defined?
Begins with an H, ends in horizontal.
Horizontal.
Oh yeah, so your tangent line, early on a Monday morning, I know. Your tangent line is going to be horizontal. What's happening with the graph? Imagine your graph. You've got a horizontal tangent line. Your graph maybe is doing like something like this. Lewis, what's happening?
Is it touching the vertex?
It's kind of like the vertex, but the vertex is a special word that we reserve for parabolas. What could you call this?
The highest maximum.
Like the highest point we could call it like a maximum?
Yes.
Now, it doesn't have to be a maximum because something else could be happening.
Minimum. It could be.
You could have a minimum. You could, like if you're thinking like parabola world, like concave up versus concave down. So if f prime of a is equal to 0, what we're going to say is the tangent line is horizontal. That's going to be our conclusion for right now. Okay. Everybody good? All right, so I want to give you guys a little bit of time to see what you can do with this. There is a problem on page 52 in your student packet here. I want to give you guys a little bit of time, see what you can do. Feel free to work with your neighbor. I at least want you guys to get through part A and part B in the next couple of minutes without much help from me. And then we'll talk some more. done with part A, keep going. Alright, so tan x equals 4. So we got square root of x. This is square root of 4 over x minus 4. Square root of x minus 2 over x minus 4. And you guys probably all know if you plug in for x, you're going to get the indeterminate form. So we have to do some clever algebra. So the limit as x approaches 4. Who's got some clever algebra for me? What are we going to do? Square root of x minus 2 over x minus 4. How are you going to evaluate that limit? Stephen, what are you going to do?
Multiply by the conjugate.
Multiply by the conjugate. So square root of x plus 2 and square root of x plus 2. Hopefully at this point we're getting really comfortable with what happens here. Maybe we don't even have to do it out the box. Polymon, what's going to happen when you multiply out the numerator there?
X and 180.
Square root of x minus 2 times square root of x plus 2. What are we going to get?
X plus 4.
Not x plus 4.
I said
X minus 4. And you guys probably know at this point I'm not even going to bother multiplying out the denominator because those x minus 4s are going to cancel each other out. Great. So we're going to get that the limit as x approaches 4, 1 over square root of x plus 2. Now I plug in. I get 1 over the square root of 4 plus 2. We get a fourth. How many guys honestly came up with 1/4? See, 1, 2, 3, 4. We get a bunch. Now, 1/4 is part of the answer. I would say I would probably award 1 point for the right setup. Probably another point for like doing the evaluation. Probably another point for correctly multiplying by the conjugate and simplifying. And then 1 point for 1/4. But part of the question though is, what does this actually tell you about the curve? What do you know for sure because of the work we just did? So Lewis, the slope of the tangent line is 1/4. This tells you something important about the curve. So one, Andrew, what did it tell you?
It's increasing.
One more time.
Yeah.
Without saying the word it.
F of x
F of x
is increasing.
is increasing. I like it, I don't love it. It's sounding a little strong right now. At
X equals 1/4.
oh gosh, oh, and I totally gave it away, didn't I? What you found, Andrew, is you found the slope of the tangent line at x equals 4. So what you can tell me is the function is increasing at x equals 4, but why? I need a why, you gotta justify. Because
The slope is greater than
the slope is greater than
0.
0, right? I could use my new fancy notation and say because f prime of 4 is greater than 0. I could use the old school notation and say because tan at x equals 4 is greater than 0. Is everybody okay with finding the value and the conclusion? Good. All right, part B. Now that you know the slope of the tangent line of the curve, find the equation. Easy peasy. You've got the slope. All I need is the equation. What's the equation going to be? I need the equation of a line. How do we find the equation of that line? Okay, you can go with point slope. You could also go with slope intercept form if you want to. Okay, point slope form is really my favorite because with point slope we're going to say y equals mx minus x1 plus y1. We know the slope. The slope is 1/4. What's the x coordinate? X minus 4. What's the y coordinate?
2.
Y coordinate's 2. David, where do you get 2 from?
I plugged in 4 to that place.
You plugged in 4 and you get plus 2, right? Now you could call this y. I'm going to call it L of x. The reason I'm going to call it L of x is for tangent line. If you want to call it y, that's fine. If you want to call it C of x for Carmen, that's fine. I'm just going to use L. I almost always use L for tangent line. Apparently, I've used that purple marker way too much. So goodbye, purple marker. Do I have you guys too? I have 939. Perfect. Everybody good with the equation of the tangent line? Now, here's the thing. One of the reasons why we study the tangent line is because we can use this tangent line for approximations. And I know this is not something that you did in the pre-calculus curriculum. So this is like the new idea. This is in part C. And I want to leave all this work up here. Stephen, if you wouldn't mind maybe turning the camera a little bit. Let's see. All right. Can you read part C?
We can use tangent lines to approximate values for known functions at given points. Using this information, we can approximate f of 4.3 using L of 4.3. Using what you know about the graph of f of x, determine whether your approximation is an overestimate or an underestimate to the true value of f of 4.3. Be sure to justify your answer.
Great, thank you very much. Are you okay? All right, so we've got the graph of f of x equals the square root of x, which I'm pretty confident everybody knows what that looks like. You guys all graphed it in the air for me? F of x equals square root of x looks like, David, what are you doing there with your hair? Okay, just about everybody did that. So there's f of x equals the square root of x. Here's x equals 4. There is some point on the curve right over here at 4, 2. Our tangent line is what I'm graphing in the red right now, L of x. What you're being asked to do is they want you to approximate f of 4.3 using L of 4.3. If I asked you to find f of 4.3 exactly, well, f of 4.3 means plug 4.3 into the square root function. And I would imagine that nobody in the room actually knows what the square root of 4.3 is. Is that a safe assumption? If I ask for an approximation, 2 and a little bit maybe? Let's go to the calculator. Get the square root of 4.3 in a calculator for me. I agree, it's a little bit more than 2. But I want more specific than that. Let's get more decimals. $2.0736. I just want to get 1 or 2 more folks to verify square root of 4.3, 2.0736. Or 2.074, if you want to be that way. Well, what's L of 4.3? L of 4.3 is just plug it into your tangent line equation. Well, let's do that. 1/4 of 4.3 minus 4 plus 2. Feel free to use your calculator if you need to. 4.3 minus 4, is that 0.3? 0.3 divided by 4, 0.075. So, according to my calculations, 2.075. Check this out. Square root of 4.3, you guys would not be able to do in your head without the calculator. Fair? L of 4.3? Can we do that without the calculator? 4.3 minus 4, I can do that. Times a fourth, add 2. Look how close those estimates are. The real answer is 2.073 and some change. My estimate is 2.075. How are we feeling about this estimate?
Good.
You should be feeling really good. This is one of the powerful pieces about calculus. We're going to take this curve, the square root function, which I can only evaluate at like nice numbers, like perfect squares, and I can build the equation of my tangent line to actually use the tangent line to approximate the true value. So this guy here, the 2.0736 is your true value. This 2.075 is your approximation. Is anybody surprised that the approximation is greater than the actual value? Let me ask that differently. How many of y'all were expecting the approximation to be greater than the true value? David, you were expecting it to be greater? Polymon, you weren't expecting? How many guys were expecting it to be less? How many guys really had no idea what to expect? Okay.
I was gonna be closer to exactly.
You thought it would be close. David, you said you were expecting it to be greater?
Yeah,
Why?
because it's coming from the left.
Because you're coming from the left.
So because like greater than 4, so it's gonna be a little bit greater.
Oh, so you were expecting that this was going to be greater than 2. I agree with you. My question is, how many of y'all were expecting the approximation to be greater than the true value? And most of you guys said you weren't really sure.
Alright. I also said because of that approximation. I said because like the tangent line.
Yep.
It looks to be like above everything, all the other values. So it's gonna have to be greater.
Okay. One more time. What I heard you say is, if I look at the tangent line is above the curve.
Yes.
Wouldn't you expect, based on what you're seeing right here, that the approximation is going to have to be greater than what the actual curve is? Right, because 4.3 is like somewhere out here. Maybe that's a little bit exaggerated. Here's the point on the graph, 4.3 comma square root of 4.3. The point I'm approximating with the tangent line is up here. The x-coordinate is 4.3 and the y-coordinate is whatever L of 4.3 is. Because of the way the curve is bending, the tangent line is above the curve, which is going to give me an overestimate. This little gap in here, this vertical gap, is going to be your error. Everybody okay? All right. So, real quick, have a conversation with somebody near you. Part D, a normal line is perpendicular to a tangent line. Using this information, find the equation of the normal line. We've got tangent lines, we've got secant lines, and now I'm bringing you into the world of the normal line. All the information you need is there. If we're talking about a normal line, you know something about normal lines. Don't overthink this. Don't overthink this. What's the one thing you know about normal lines? Polymon, what's the one thing you know about normal lines?
It's perpendicular.
It's perpendicular to what?
And
Perpendicular to the tangent line. Now, I know it's been a while since like Algebra 1 and Geometry, but you guys know something about perpendicular lines? What do we know about perpendicular lines? What's the important thing? Okay, you're like warding off vampires there with your T. You're right? They're like they intersect like this. We know something about their slopes.
They're opposite.
They are opposite reciprocals of one another. So if that's true, and if this guy here in green represents my normal line, we've got secant lines, we've got tangent lines, and now we have normal lines, what's the slope of the normal line? Doesn't it have to be, I heard 1/4? Negative 1/4. Right? Because you know the slope of the red line,
Opposite reciprocal.
it's the opposite reciprocal. You guys, oh, yes, thank you. Okay, the slope of your tangent line is 1/4. The slope of the normal line is the opposite reciprocal. So it's going to be -4. So the last thing I want, what's the equation for the normal line? -4,
Parentheses x minus 4.
parentheses x minus 4,
Plus 2.
plus 2, because I still am using the same point of tangency. The slope of the tangent line was 1/4, the slope of the normal line has to be -4. Now what am I going to call it? This is important, don't get it wrong. What are we going to call it? Don't call it y. Don't call it f of x, we already have that. Don't call it L of x, that's our tangent line. Call it whatever the hell else you want to call it. So how about like n of x? Is okay? All right, good. And we've got 11 minutes, which is about where I wanted to be, so I'll take that as a good thing. We've got one more way that I want to talk to you guys about the tangent line and finding the slope of the tangent line. And it is totally your choice. We have two really powerful ways. There's one more, and I'm going to go a little bit faster with this than I would with the AB kiddos, but you guys are going to be okay. This goes back to what we were doing with Geometers Sketchpad earlier. If this is the point x comma f of x, if I want to find the slope of this tangent line, what's the story? What do we do? We pick one more point. If this is the point x comma f of x, the other point that I'm going to pick is some distance away. I'm going to call that distance h. That means that this guy here, the x coordinates are going to be x plus h. The y coordinate is whatever f of x plus h is. You guys know the story. I'm going to connect that with a secant line. And if I said, hey Andrew, what's the slope of the secant line? What's the formula for slope of the secant line here? What would you tell me?
F of x. Wait.
Slope of secant line. The red line, the one that connects this point here and that point there. What would you do?
F of x plus h
F of x plus h.
minus f of a.
Oh, hold on. F of x plus h, I agree, minus f of x
over h.
over h. Now I want to make it really obvious why it's over h, because if I'm thinking slope, I'm thinking change in y divided by change in x. F of x plus h minus f of x divided by x plus h minus x. You said just h, and you're right, because that x and that x are going to cancel each other out. Is that slope of tangent line? Why not, Dan?
In order for us to find the slope of tangent line, we need to find the limit.
You've got to find the limit, and you've got to find the right limit. If what I want is slope of tangent line, what's the right limit to find?
Limit as h approaches 0.
Limit as h approaches 0, f of x plus h minus f of x all over h. This guy here is what we're going to call f prime of x. This is the derivative. What I love about the derivative, unlike that other version we worked with, the f of x minus f of a over x minus a, you needed to know one particular point, and it gave you slope of tangent line at one particular point. This one I'm going to consider the more generalized version, because this works for any particular value of x. I get to work with a variable versus a particular number. So let's try it over here with this one problem. We're going to work on the square root of x again. And for all of you that like going to something called Wolfram Alpha to do all of your heavy lifting derivative work, this is actually what Wolfram Alpha is doing behind the scenes. And also, please don't go to Wolfram Alpha and have it do your derivative work. That's your job. All right, f of x equals the square root of x. I want to find f prime of x, which means limit as h approaches 0, f of x plus h minus f of x all over h. For this particular function, f is square root, so we have square root of x plus h minus the square root of x all over h. Is everybody okay with the setup here?
Yes.
Okay. I want to take the limit as h approaches 0. What happens?
Not possible. 0 on the denominator.
You're gonna get 0 in the denominator. How about the numerator?
You get 0.
0 to
We're gonna get 0, right? Because what you're getting is square root of x minus the square root of x over 0. 0 over 0, we know, indeterminate form. So what's the tricky algebra that we're gonna do? Stephen, what are you gonna do?
conjugate.
You're gonna multiply by the conjugate. For this particular problem, Stephen, what's the conjugate?
Square root of x plus h plus square root of x.
Okay, I heard square root of x plus h plus the square root of x. Square root of x plus h plus the square root of x. Giselle, question for you. Is that legal? Why? It's fancy one. Okay. Now, second part of that question though. Is that better? Are we expecting this to give me something better? Looks like maybe we're not sure. So let's try it and see what happens. Limit as h approaches 0. Square root of x plus h minus the square root of x gets multiplied with the square root of x plus h plus the square root of x. Check it out. Do the box if you need to, or let's just see if we can do this mentally. Square root of x plus h times square root of x plus h. X plus h. Okay. Now this guy times the square root of x. And then what happens? Negative square root of x times the square root of x plus h. What's going to happen there? They cancel. I've multiplied the first and the first and the last. These guys. Negative square root of x times positive square root of x is going to be negative x. In the bottom, I am not actually going to multiply this out because I kind of have a sense of what's going to happen here. The x and the negative x are going to cancel out. Palimon, what else is going to happen here? The h is going to cancel out. And you want to be careful. That h and this h cancel out. And the big mistake that a lot of folks that aren't comfortable with the algebra are going to make, they're going to say, oh, what you're left with is the square root of x plus h plus the square root of x. Myra, do you know what the mistake is they just made? What they Yeah, you still have a fraction. The x is canceled. When you divided out the h, you're left with 1 in the numerator. Now let's see what happens if we take the limit as h approaches 0. H gets close to 0, square root of x, plus another square root of x. What you're left with is 1 over 2 square roots of x. That guy there represents the derivative of f at what point?
Any point.
Any point. This is tan at every point. At every point on the curve. So for example, what's the slope of the tangent line at x equals 4?
1 over 4.
At x equals 4, square root of 4 is 2, times 2 is 4, 1/4. Is anybody surprised by that? I would hope the answer there is a strong no, not surprised. We already did all that work, right? Like part A, when we first did that exploration, you got 1/4 as an answer. This guy here confirms that belief. What if I asked for the slope of the tangent line at x equals 9?
6. 1 over 6.
Man, you guys are getting really good at the whole derivative process, right? The other way you would do it is say, oh, it's limit as x approaches 9, f of x minus f of 9 over x minus 9. Guess what? Isn't this better? All right, I'm curious, can you tell me a point on the curve where the tangent line has negative slope? Where will the tangent line have negative slope? Don't talk to me, talk to Nick. Where's the tangent line going to have negative slope? Trick question. Where's the tangent line going to have negative slope?
Nowhere.
Lewis, why nowhere?
Because the square root of x, you can't, that's undefined.
The square root of x, you know something about this. The square root of x is always going to give you a positive answer. So what do you know about the slope?
Will probably be positive.
It's only ever going to be positive. Does that fit what you know about the graph of the square root of x? Square root of x is increasing from left to right. So if the graph of the square root of x is always increasing, what do you know about the slope?
Always.
It's always positive. Your derivative here is always positive. There is one time, though, when the derivative is not positive. There's one place. There's one point on the curve where the derivative is not positive. And I won't tell you where.
At the vertex.
Stephen, where?
Vertex at 0, 0.
Careful, you're using the word vertex, which I reserve for parabolas. The graph of the square root of x looks like this. That doesn't really have a vertex.
At the minimum.
At the minimum, can you give me an x value there?
0.
At 0, what happens here at 0?
1 over 0.
You get 1 over 0, which is undefined. So at that point, the derivative is not positive. All right, so tonight's homework, it's assignment number 7. I want you to do round 2. I want you to at least do the first 3 problems in round 2. Doing more is a good thing, David, but at least do the first 3. I think there's 5 problems total. At least do the first 3. We'll talk about this tomorrow. See you guys later. Bye, Trailblazers.